This is less than 95, and we are correcting a PowerPoint error. We are adding and subtracting rational expressions. Rational expressions are fractions that have variables in the denominator, or variable expressions in the denominator. So what we're doing here is adding and subtracting algebraic fractions. A little bit more complicated than what we did back in lesson 90, but lesson 90 was also adding and subtracting rational expressions. Problems 1 and 2 from last night's homework are what we're doing today, more of, from lesson 90. But these are going to be a little bit more involved. Okay? Adding and subtracting rational expressions, algebraic fractions. Now, what do we already know about adding and subtracting fractions? You have to get the denominators the same. We're going to find an LCM. And using the LCM, which is the same thing as a common denominator, Jay, this is lesson 95, son. It's written on the board. We have you have to get common denominators, which is the least common multiples, just like what we did in the bell work assignment just now. All right, so adding and subtracting rational expressions involves getting common denominators. So we're going to deal with number 1 here. I'm sorry, this should have been written there. My PowerPoint's not acting right. I'm going to rewrite this. 3 over x plus 3 minus 9 over x squared minus 2x minus 15 is the problem we're working here. You need to factor, right? How do you know we're going to have to factor this? Because the denominators aren't the same, so I need to find an LCM. And how do you find an LCM? By factoring to see which factors are missing. So I need to see, obviously, I think, or maybe it's not obvious, but we're going to be missing a factor in this denominator on the left. On the right, x squared minus 2x minus 15 will factor as
x minus 5 times x plus 3.
There you go, x minus 5 times x plus 3. And now it becomes clear what's missing in the denominator on the left in order to make these denominators the same. What am I missing on the left? X minus 5. So I need to add a factor of x minus 5 to the numerator and denominator. What I'm really multiplying by here is 1. X minus 5 over x minus 5 equals 1 as long as x is not equal to 5. And then it's nonsense. But I can now combine the numerators. The numerator on the left will be 3x minus 15 minus 9 over x minus 5 times x plus 3. Simplify. What's negative 15 minus 9?
Negative 24.
Negative 24, right? Now, it's going to be 3x minus 24 over x minus 5 times x plus 3. And we have to make sure that this fraction can't be simplified. The numerator can cancel. I mean, it can factor, can it? It can't cancel. It will factor as what?
3 times x minus 8.
3 times x minus 8. Will the x minus 8 cancel?
No.
Will the 3 cancel?
No.
No, so we can inspect that mentally and see that this is already simplified. Leave the numerator multiplied unless it can factor and simplify, and then you can factor and simplify it. Yes?
So you didn't want us to simplify the numerator?
No, the numerator is simplified.
But the denominator usually is factored with either x minus 5 or x plus 3.
Yeah, now we want to leave the denominator in factored form, guys, because we can see some things really readily there, right? Now, Savannah, don't factor the numerator. You asked, do we want to not simplify it? Remember, factored is not simplified. Factored is in multiplied pieces. Simplified means it's been multiplied together. 3x minus 24 is simplified. 3 times x minus 8 is not. So leave the numerator multiplied together unless it can simplify. We want to leave the denominator factored always, because what can we see immediately from this expression? What can we see immediately by looking at this fraction? The undefined values for x are what, Jackson? Right, vertical asymptotes. If this was a rational function, x cannot be 5 and x cannot be negative 3. So we can see that, and that's why we want to leave the denominator factored in a rational expression. We wouldn't want to multiply that together and get x squared minus 2x minus 15. Okay, next example. 2x over 4x squared minus 196 plus 12x, and I'm going to rewrite this so I can have room. 2x over 4x squared minus 196 plus 12x over x squared plus x minus 56. As you're right. I just couldn't really see there. Okay, now we got to factor these two expressions in the denominators. This is 2x. 4x squared minus 196.
The difference is squares. It's the difference is squares.
It's 4 times x squared minus 49. I'm going to do this in 2 steps. Watch. This is 4 times x squared minus 49. But x squared minus 49 will factor further, won't it? It factors as the difference of squares. X plus 7 times x minus 7. Okay, and my denominator on the right will factor as
X plus, no,
plus 8 times
yeah.
minus 7, x minus 7. So I got a mess here, don't I?
Pretty much.
I got to make my denominators the same. Okay, now what can I do here to make my denominators the same? What's missing on the left side if my denominators are going to be the same? X plus 8 is missing. So I need an x plus 8 and an x plus 8. What's missing on the right if I'm going to make my denominators the same?
A 4 and an x plus 7.
A 4 and an x plus 7. Now, the bottom is a complicated mess. And that's another reason why we like to leave it together. I'm going to leave the denominator is just going to be 4 times x plus 7 times x minus 7 times x plus 8. And I forgot something up here, didn't I? I need to multiply this times 4 and x plus 7. Do you want to multiply that denominator back out? No. We're going to leave it that way. Now, on the other side, I am going to multiply, excuse me, not the other side. In the numerator, I am going to multiply that out as, I'm going to slide over here a little bit, 2x squared plus 16x. I didn't give myself enough room. And then on the right side, I'm going to have 48x squared. 48x times 7. What's 48 times 7? 336.
336.
It is 336. 336x. That is all over 4 times x plus 7 times x minus 7 times x plus 8. What a mess. Now I've got to simplify the top, right? Add those together and I get 50x squared plus 352x over 4 times x plus 7, x minus 7, x plus 8. Now I'm guessing something's going to factor up top. 352 is divisible by 2. Is that the only thing we got to work with?
No. 25, that doesn't make sense.
We're only interested in numbers that would result in an x plus 7 or an x plus 8 or an x minus 7. Will 8 go into 352?
Will 8 go into this?
How many times does 8 go into 352?
44.
44 times. But 50 is not divisible by 8 or 44. So is the numerator going to factor into something that we could cancel with the bottom?
Yes.
What?
2 times 25x squared plus 176x.
Okay, 2, you're exactly right. That's the only thing we can take out of the top. So we can take out a 2x. Let's go ahead and take out a 2x. 25x plus 176
Yep.
over 4 times x plus 7, x minus 7, x plus 8. And now this 2 will cancel with this and leave us with the 2 in the bottom. Okay, now I want to show you something that's going to help. Y'all listen. At the very outset of this problem, we could have canceled that 2 with that 4, and we wouldn't have had to do that last step at all. All right, now we didn't get through a lot of the examples, but we're going to go ahead and move through this anyway. Your assignment is, it is page 634, A through F, 1 through 11, 18, 21 through 23, and 28.
Is it for accuracy?
It is not, because we didn't get our enough examples in today.